Student t-test for unpaired or unrelated or independent samples in Jamovi. The student t-test is a parametric test that is performed when there are two groups of data and the two set of data are normally distributed and the variance is equal or approximately equal for both. Those are the two assumptions or the main assumptions that are required to do t-test. The data has to be continuous and normally distributed, and the variance for both groups are approximately similar. Then the test can be used to find out whether there is a difference between the two groups. Here in Jamovi data view, I had inserted a data for 100 participants. There are two groups of participants: gender, which has males and females in it, so there is one variable which is categorical and it has two levels in it, males and females, and a continuous variable which is the height. The height of each participant were measured in centimeters, and the score is recorded here. So there are two groups here, the male group and the female group, and the height in each individuals are measured. So these two groups are separate, they are independent, they are unrelated, unpaired. To find out whether there is a difference in the height between males and females, then the unpaired student t-test will be performed. To do the analysis, click on the icon for analysis, then select the icon for t-test, and then select independent sample t-test. A new window appears here. Going to move the gender, which is a grouping variable, into the grouping variables, and the continuous variable, which is the dependent variable, the height variable, into this box. Simultaneously, an independent sample t-test is performed and a table is generated showing the student t-test statistic value 4.5 and a degree of freedom 98 and a p-value of less than 0.001. This p-value is significant as it is less than 0.05. To add further and additional statistics to the output of the Jamovi, tick on the mean difference and then tick on the confidence interval, and as shown here, the mean difference is given here and it is a value of 9. So there is a difference between the two set of groups, male and females, and the standard error difference is given here. Also here added the 95% confidence interval, which is another value that add more confirmation to the analysis. It has a lower and an upper value of 5.06 and an upper of 12.9, and the mean difference fit within this range. So this again confirmed that the observed difference in the mean is significant. To add further description, we could tick on the descriptive statistics. From the descriptive statistics table, the height for male and female and the number of the participant is shown here. The mean for the male for the height is 169 and for female is 160. So it's already shown that the males are taller than females, and also the median is higher for males compared to females. and a standard deviation is given here, which is 10.5 and 9.2, and a standard error also. We could also tick on the descriptive plot to generate a descriptive plot for the two groups, male and females, and the mean and the median as shown in this plot. We could also select the Welch test if we think that the two groups have an unequal variances, then we stick to use the Welch test. Otherwise we stick with the original observation or calculations here, as a Welch test is calculated and it gives similar values. We could also take the Mann-Whitney test when the data are not normally distributed, but in our case here the data are normally distributed. By how? By checking and ticking on the assumption check here. If we tick on the normality test, we can see here that a test of Shapiro-Wilk is performed for the height, and it shows that the p-value is greater than 0.05, and this indicates that the data are normally distributed. We could also take for homogeneity of variances, or what we call it Levene's test here, Levene's test. And also the Levene's test table shows a factor of 0.76 and a p-value of greater than 0.05, which indicates that there is homogeneity of variances, and the two variances for both groups are approximately similar. We could also tick on the QQ plot and generate a QQ plot, which shows that the circles here fit along the side the diagonal line. So from this output we can conclude that there is a significant difference between the tallness of the males compared to females, and the females are shorter than males, and this observation is statistically significant. So this is the way to perform student t-test for unpaired or independent two samples in Jamovi.